everybody. My name is Alexey Krabarov, and this is the plenary panel on open source science. Welcome to this first panel of the very first IEEE Open Source Science Symposium. And I'm very happy to be here and introduce our panel. Before, I'll just say a few words how this area started. So I'm a director of open source science at IBM Research. Open source science is an area of human activity connecting open source software, data, processes, and science. So at IBM, we started this as a formal initiative last year. We launched it at SciPy. And at IBM Research, open source science initiative is actually a community activity which belongs to NumFocus. So it's actually not corporate property. It is a communal activity formally established at NumFocus. And just show of hands, who knows what NumFocus is? Okay, who knows what Jupyter is? Notebooks, right? Everybody. So this is kind of the story of NumFocus. So NumFocus is the software foundation most established in data science. It's a 10-year-old nonprofit headquartered in Austin, Texas. And it was set up by Travis Oliphant to be a home for NumPy. NumPy by Submetrics is the most deployed open source project in history. Any numerical programming set up in Python mostly uses NumPy, right? And we have 95% of data science in Python, and then it grew, it added SciPy, Pandas, scikit-learn, Jupyter, so marquee names in open source. And by virtue of establishing open source science, at NumFocus, we connect with the community of open source developers and researchers who advance science with open source, right? And so we're very happy to start, the very first IEEE Open Source Science Symposium. I'm very thankful to Ron and Jeffrey and all the leaders of IEEE services. I think, this is very timely, given that open source gave us commodity data centers and internet and now AI, right? This is all basically open source based. So we live in the world where open source software and data make huge difference. So we have a great panel here. Let each panelist introduce themselves, going from Anthony on the left.
Thanks, Alexey. Hi, everybody. Good morning. It's really a pleasure to be here. I'm Anthony Annunziata, and I lead what we call our accelerated science programs in IBM Research. IBM Research is an interesting organization by industry standards, I think, because we still do pursue foundational and applied science alongside technology development and commercialization for the company. About a year ago, as Alexey mentioned, as we were really starting to try to ramp these programs, we knew that open source, that open community would be a huge component of this. And this is why we got so strongly behind the open source science concept. Now, one of my favorite parts of open source science is the community aspect of it, and in particular the community dynamism, the diversity of the community, the ability of the community to respond and to engage so quickly. If you think about that, and we see this in the AI field incredibly vividly in the last months, when something is open sourced, the community can jump on it overnight and innovate further and apply it further. I think that aspect, that speed of innovation is really unmatched. I don't think it can be, I think the community way of doing that is the way to accelerate progress faster than any other way we could do it. Another really important angle, if you think about it, is that the community can respond to really important efforts to bring more people with more diverse backgrounds into the technology development and the science field. If you think about how long it takes a company to change the nature of its workforce, it can take months, years, a decade. The community, that can happen overnight as well. So that's also really interesting and a very alluring aspect, at least personally to me. Now, the topic I wanted to bring up for further discussion is that open source means a lot more than just code now. It's data, it's results, it can be access to infrastructure, it can be educational content, and so on. And there's an increasing acknowledgement that there's strong mutual benefit. There's benefit for a lot of this being open, but where's the line, right? Where's the line? Certainly organizations, commercial or otherwise, government organizations must hold back some things. Some things are rightfully proprietary and sensitive. Some things are obvious, things that are personal to an individual. A lot of things are less obvious. So one of the questions I like to pose and discuss in the panel is, where's the line? Where are the lines? What should be open moving forward? What are things that we should all agree that probably shouldn't be open?
Thank you. Dean?
Hi, I'm Dean Wampler. I used to work with Anthony till recently on IBM's initiatives with accelerated discovery in science. And most recently, I started working on our AI initiatives, including the questions about what models should be open source, what data sets, and so forth. I got my start doing computational physics in grad school and discovered a love of programming, and have mostly spent my career working in commercial software development as opposed to like scientific research. And one of the things that became clear to me, especially in this time at IBM working with scientists who were trying to open source their software, their results, and so forth, is kind of the divide between, the suitable way to write software for scientific research versus the kind of requirements you have when you try to open source something that other people can rely on, that might be used in ways that you didn't anticipate, might have requirements for availability, resiliency, scalability, all those kind of ilities that we talk about in software. And so I started thinking a lot about the divide between these kind of different goals that where the software started and where it ends up, and how do we bridge these gaps to make software truly extendable from the research environment to like the production environment, the commercial environment, et cetera. Because obviously, if like at IBM Research, we want to make money on our research. We have to in order to survive. So I think the big topic I'd like to discuss with the panel then is this question of how should we be developing software today, both to support our needs for research, but also to support the need to make it open and to allow other people to leverage what we've built. And I think it's particularly interesting when we talk about ways in which AI is probably going to change the way we write software in very fundamental ways as well.
Thank you.
Hi, everyone. My name is Paige Martin. I am a program scientist at NASA as of a few months ago. But my background is as a physical oceanographer and climate data scientist. And until November, I was working as a postdoc in the climate data science lab at Columbia University. And I'm also on the Pangeo Steering Council. Pangeo is a community for big data geoscience. And I am also part of open source science, why I'm here today. I agree with a lot of what has been said, and one of the ways, I'm actually going to give a talk later today, and I'll go into some more detail, but one of the ways that I really came into open source software in my own scientific research was scalability, so one of the ilities. And I did a lot of ocean model data analysis, and ocean models are really, really big. We like to resolve really small scales in the ocean, which means you have to have really high resolution models. And so these data sets are really large. They're also multidimensional. And so they're very complex. And I found that the open source tools were the only way forward for me to actually scale up my analysis to be able to do these kind of global ocean model analyses, especially because I was doing a lot of time series analysis where I needed the full time series and the full global domain. And so I couldn't chunk things up quite as easily. So anyways, the scalability was one of the really important aspects for me of open source software. So the main thing that I was going to bring up is echoing what Anthony said about community. So open source science and open source software to me is largely about community. I think when I first started, I kind of didn't separate out the fact that I was using open source software that was free. And so I kind of equated it with being free, but that's not always the case. Free and open source can be distinct. But the real part of open source for me was that there was a community that anyone can be involved with. It's fully transparent, anyone can see and interact with the source code. And I found that really fun. And I've done some teaching in West Africa. It was really apparent how helpful open source software is in the sciences there, largely because it's free, but also because there's a community where they can kind of quickly adapt, like was saying, that they can join right away and have a real impact. So, so that's kind of what I wanted to focus on today. And so my main question is kind of on that community side of open source. Is our ideal all community-driven open source software in the sciences? Should we still have commercial software? How could they interact? You know, can we have community-driven, have all the benefits that commercial software might give us? So those are kind of the questions that I wanted to ask the panel today. Thank you.
Thank you.
Hello, this is Ernesto Damiani from the University of Milan in Italy. I was very sort of delighted to have the opportunity to be on this panel for a reason that I bring a little bit of continuity with the past, in the sense that I gave the keynote in 2008 at the IFIP first workshop on open source that was held in Lake Como in Italy at the time. And that my keynote at the time was Trends in Open Source Research. So it's very nice to be here and sort of, to be able to compare the vision, traditional, we can say traditional because open source is nothing new. It's sort of been around for a long time. So the traditional vision and the continuity with respect to the new effort on open source science that I see are emerging now. And I would like to offer just one perspective on this. There is one side which is open source for science, and certainly there are a lot of new ways by which open source, the notion of open source is now of interest for the science production process. And I would like to underline the notion that today we have a lot of open models as well. So that's a perspective that is not open code, it's open models. It's becoming more and more important. On the other hand, there is the notion of science for open source, in the sense that the open source itself is enabling or potentially can enable new ways to increase the productivity, to increase the outreach, to increase the sustainability of the work of the scientist, of the science community. And in order to do this, we need to research how. It's not the turnkey. It's not that because it's open, it will work. It will work if we have wisdom together with the paradigm. So this is the continuity I would like to bring. Many of the trends that we identified in 2008 are now mature. And I think this is the moment in which you can reap, the benefits of the entire set of ideas that goes that way. My question for the panel now. Well, you know, at the time, those trends were identified. In 2008, we were looking at the globalization in its full development, blossoming out. And it was natural thinking of a planet-wide community of science where the open source movement could be part of this overall thing. Today, we are looking at decoupling, regionalization. So I think that there is a potential conflict in here. Because, of course, the potential of the community as the author of a collective effort was designed in a time in which the community had no boundaries. And today, we might be facing a world in which this is not exactly always the case. So do you think of how shall we sort of survive in a regionalized context with this open source, open science idea? This is my question for the panel.
Thank you.
My name is Carlos Maltzahn. I'm a faculty at UC Santa Cruz and been actually an adjunct professor, but acting like a real professor. I've been funding myself and my research group for 19 years on soft money. I was very lucky that I was able to graduate my 10th PhD student just 2 weeks ago. And I think one of the career-defining events that happened to me that I met a student called Sage Weil, and I started working with him in the summer of 2005, where we actually created a little project called Ceph, and was then able to follow that project from literally starting the project and giving it a name to now being part of the storage portfolio of IBM. And so that's been, you know, an amazing journey. And I can tell you that, you know, Ceph as an open source distributed storage project is a poster child of what open source can be, both for industry and for the university. It certainly changed the attitude at UC Santa Cruz towards open source. So when Sage created a startup called Inktank and then sold it to Red Hat in 2014, he actually, as part of, you know, him having become very rich, gave me $2 million to create an institution at UC Santa Cruz that would enable students to have a similar experience as he had in, you know, bringing out their research in form of open source. And so we created the Center for Research in Open Source Software, also called Cruz, which raised in 5 years $2.4 million in membership, industry membership fees. So there were like $2 million from Sage, then $2.4 million in industry membership fees. That was money unheard of in connection with open source. That success has then allowed us to get further funding from the Sloan Foundation to create one of the first 6 open source program offices at universities. So we have an OSPO now at UC Santa Cruz, and we're building a network of OSPOs for the entire UC system. So the 2 things, I think the 2 questions or the 2 statements I would like to make is, first of all, open source science. I think the most exciting 2 work groups for me are the work groups on mapping the open source and science. So one thing that I think is a huge missing piece in the open source world, especially in universities, is an awareness of how open source can leverage, or how scientists can leverage open source, and how they can not only use that open source, but also contribute to it. And then the second part was that we, I think that the question to the panel is, how can we show the value of open source at research institutions like universities? Universities are very unaware right now of the value of open source within their research communities, especially the leadership. So just as an example, UC San Diego recently discovered that 30,000 repositories were associated with researchers, and these were just GitHub repositories. There are also probably GitLab, Bitbucket, so forth, right? But these are 30,000 public repositories. So even if only 10% of it is of any value in terms of community around those repositories, that's still a big number. And that just blew away the leadership. And I think we are actually in the process of doing this for a number of other UC campuses right now. It's actually data that's readily available. You can go to use a GitHub API. You can use, you know, other public repository exchanges and actually figure this out. So this is like a trove of data that's sitting there that, you know, it's just an example of how we could make this value more visible. And that will really, I think, advance policies and also compliance within the research organizations. Thank you.
May I borrow your mic? This is Hridesh Rajan. I'm a professor and chair of computer science at Iowa State University. And I have a little bit different background than my colleagues here on the panel. I approach open source science from the software engineering perspective. And just to state the value of open source science and open source for software engineering community, the community itself has significantly benefited from open source in the sense that it has allowed the community to do empirical evaluations at scale that were just not possible before, because the real software development activities were not visible to an average person in the university. So software engineering community, research community definitely values open source and related activities quite a bit. I think about open source from the perspective of studying open source and software development activities, and how could folks do that at scale. So how could one look at open source activity and determine what is working across projects, what is not working across projects, what programming practices are effective, which are leading to more bugs. So to enable that, we have worked on an infrastructure that is utilized by 35 countries, many researchers, thousands of researchers in the country that use this infrastructure to study open source and software development activities within open source. And this work has been going on since about 2013. And this allows folks to not have to worry about cloning GitHub to be able to study what is happening in open source. Further, one of our key goals was to enable reproducibility in this area. How do you, because science, if you're trying to study a phenomena, if person A studies a phenomena and person B studies the same phenomena, if they're not able to compare the results, that's not a very good place for science to be. So we are really interested in ensuring that reproducibility is enabled in this area. So I have been also started to think about open source, especially open models, in open AI models in this area. This is very much on my mind. And what keeps me up, nowadays, is there is a lot of work going on in using models to write code. A lot of work going on. The industry players are very active in this area. They are leveraging work done in open source to enable those models. So what are the copyright issues around that? If could someone take my work and then train a model using that work, and then that model then produces new code? What does that mean? I think that's something that open source community will have to grapple with. Other question that I think is really, really important for the open source community is that availability is not going to be the same as accessibility. And I will talk about that in a little bit more detail later on. So what I mean here in a nutshell is that, let's suppose you wrote a Python package and you made that Python package available as an open source. Yes, somebody can download that Python package and utilize it. On the other hand, if you took a model architecture that had many, many layers, and you made that model architecture available as an open source project, that really doesn't mean very much anymore. Because even if somebody had access to that model architecture, they may not necessarily have the compute, they may not necessarily have the data necessary to really get the benefit out of that architecture. And that is something that we as a community will have to grapple with. What does availability means in this new era? And I think about that very much, and I would very much like the opportunity to think about these and similar issues with our colleagues here on the table.
Thank you. So I think we really have a broad set of questions, and maybe I'll pick up on what Carl said, because I think everybody has this challenge. Maybe we'll expand a little bit. How do you demonstrate the value of open source, right? Because we basically use open source software data models in a business context, in an academic context, right? And each of you working, for a number of years in this area. So, I wonder, if each of you can share kind of the most positive and most challenging experience, which kind of illustrates the context of your work, right? So because we have industry here, we have academia across different institutions. So if you can share, some ways you could demonstrate value, maybe mention the use cases where open source really helped, but also maybe illustrate what kind of challenges you have to overcome when introducing open source in anyone. Yeah. Sure.
Yeah. So I'm in academia, so a lot of my work is, what I say will be relevant from the academic context. One of the key challenges in academia is valuing open source as a product. So those who are not in academia probably are not familiar with these ideas, but there is such a thing as promotion from assistant professor to associate professor to full professor, and so on and so forth, right? And each of these steps, does your open source project matters as you're being evaluated? And this is where one of the positive ideas that we are happy to share is that data and open source is more valuable today in academic context than it was perhaps 10 years ago. And it hasn't happened in isolation. There has been a lot of work done around demonstrating value of open source, that open source projects are publications too. In fact, they might lead to more impact than a single paper. And I think that's a positive story that we should talk about more often, as to how the projects are being valued in career advancement of people around the world. So I will stop at this point. Yeah.
Thank you.
I have some suggestions, if I may. If you really want your project to be successful as an adopted as open source, there's a few key things you should do. And this is speaking as someone who's way too busy, who has to evaluate a lot of packages. First thing I look at is, what's the license? Is it something I can actually use freely, like Apache license? Second, does it have a good README that explains what it's about and tells me how to get started with it? Does it have an example I can run in 5 minutes to see if it actually works and if it looks like it's interesting for me? So if you think about what the end user experience is for somebody that you want to appeal to, those kind of things are not hard to do, but they make a big difference in terms of getting some traction for what you're building.
I like to disagree for the last part. They're actually hard to do. So getting a good experience for an open source project is hard. It's actually, it's something that the NSF recently acknowledged with their new program called Pathways to Open Source Ecosystems. And it's a two-phase project. One is trying to sort of scope out what is actually the community for a open source project. So it's the community discovery of an open source project. And the second one is to actually build the infrastructure. And the new thing about this funding is you cannot pay students to do it. That is very important. And it's actually the reason for that is they want to encourage that universities build institutional support, meaning staff that build those open source ecosystems for open source projects, to actually create that experience, right? And if you think about that, good open source projects have a lot of things that research products don't have usually. One is they have onboarding, they have documentation, they have debugging, they have continual integration, continual deployment, all these things that you want to see when you evaluate an open source project are typically missing from an open source research product. Which usually only has a student and maybe a researcher, maybe a faculty behind it. And they are not even trained to do these things, right? And so they sort of try to teach it themselves, but it's actually, everybody is super busy trying to publish, trying to do the things that they get evaluated for. They do not get evaluated for an open source ecosystem for their project. Unfortunately, it's only a indirect benefit. And I agree that, the papers that I publish that we're connected to an open source project get consistently more citations than papers who didn't have an artifact associated with it, right? That people could access and use.
And I just want to add that not just developing, but having a sustainability plan. That's very, very important. Because once there is a following of the open source project, once there are people who are depending upon that open source project, if it is not kept up to date, if not kept compatible, its value degrades over time. And that sustainability plan is actually very hard to put together in a way that doesn't burn graduate students out. So
I'll chime in here. So I am relatively new to NASA, but I'll start with a perspective from a government agency and a funding agency. I think we see a lot of benefits of open source science and open source software and science, and that's why I actually have a job at NASA. I'm hired full-time to support open source at NASA, which is pretty cool. That job didn't exist before I applied for it. And one example of that is the Mars Ingenuity helicopter. NASA created a helicopter that flew on Mars, which is pretty cool. And its software called F Prime was developed open source through JPL. And they developed it openly, and it's been released openly. I believe about 12,000 people ended up contributing to it, which shouldn't be a surprise to many of us because you have a lot of dependencies that everyone's contributed. And everyone on GitHub who did contribute to that got a little badge saying like, hooray, you helped contribute to this awesome science project. And it's also now being used for things that are not just on Mars, but on Earth. So like drone science that involves like drone flights and that kind of thing, even on Earth. So I think that's a really good example of kind of a NASA success story. And we really realized that a lot of what we do wouldn't be possible in the time frame that we're doing them without the help of the open source community. On the other side, there are a lot of challenges from a funding agency and a government agency. So going to the question of what should be open, there are some things that a government agency can't make fully open. A lot of the data, software. But more than that, as a funding agency, we are here trying to fund, the next software and trying to fund people to maintain the software that they're using. And we need as a community to make sure that we have ways to measure that so that we have metrics. And this is something, before I started at NASA, I kind of always rolled my eyes at metrics, like, well, they're kind of silly. But that's kind of how we base everything. We need more of this like science on science. I mean, Carlos was saying, he gets more citations and papers that have to do with open source. That's potentially one way of measuring. That's how we kind of currently measure things is based on how many citations you get. But this is really important for funding agencies who want to do the best things for the community. But we need ways to know, how will this actually impact the community? What will have the most impact that we can provide funding for? So that's kind of the funder perspective. I also have an early career perspective. So some of these are kind of my personal views. I think a lot of what we're talking about here really comes back to the incentive. I mean, everything is the incentives. And I think a lot of the way that we do incentives in academia and in science are broken, including that papers are kind of our sole currency. So as an early career researcher, if I'm looking, to get promoted to get a job, it's pretty much only how many papers I have and how many are high impact journals. Now, different fields are different. That was my field. And things like I took the time to, address some bugs in an open source software package. That doesn't get counted. If I get involved with the community, so I'm involved with the Pangeo community, I've put a lot of time into organizing events and that kind of thing to have these discussions. That doesn't get counted at all. Now, I'm being a little strict here. Some places do. It really depends on the university or the institute that you're applying for a job. But for the most part, those aren't counted. So when we're talking here about, like the software should count like a paper or should be a real product, I think absolutely software should be its own product, but we really need to broaden our view of what kind of counts. And I don't think it should even be, it doesn't need to be tangible things. It's how we're spending our time and how we're contributing to the community.
I don't know if maybe Anthony, you want to go last or you want to go now?
I can,
Because
yeah, I have a
we
few
just
further
waited.
thoughts.
Okay.
Yeah,
So,
sure.
yeah.
Yeah, look, that was really great. I agree with almost everything stated. I'll just add one or two points. Look, I don't think that all open source needs to have the same metrics of utility. And in fact, there's 2 or 3 flavors, at least, I'd say, of utility of open source. Just because something is not going to be robust enough and built out enough and catch on as a downstream commercialized product doesn't mean that doesn't have huge utility. There's a value, I think, in and of itself to just making code, making data sets, making results accessible and investigatable to the world. Now, those projects may not have all of the standards that my pal Dean Wampler expects, and that could be totally fine. On the other hand, there are certainly projects that need to have the amount of critical mass of maturity that the Dean is talking about here. And those are products or future products, right? Things that will have mass utility and use. So I think there's a spectrum of utility, and not all open source is created the same. If you look at the 30,000 repos mentioned, it's probably okay that most of them will never be downstream products. There's still utility in having that open.
Yeah, but if I may, to try also to wrap up what I heard, which is all very, very well, but I think we need to draw a distinction. I mean, we are not talking, we are not only talking about the open source development or open source software, because we have been there, we have done that. I mean, Open Office. I was in the project we wrote a book on certification of Linux Red Hat so many years ago. That has been done. I think that the new thing that is emerging is this open science part. In the open science part, the open software is not a choice, it's a necessity. It's the only way where you can enable certain dynamics. And some areas, by the way, IBM, I shouldn't say that being known, but IBM have been involved in a lot of those initiatives. In some science areas, the open source side is a necessity because the huge community must be recruited. The products must be evaluated. The only way is to have them not as papers, but also as the open source models that can be sort of, compared. For example, there was a very interesting paper by IBM on how do you early detection of good ideas, not from papers, from the models, the open models that are attached to the papers in a number of areas. So I think that the new perspective is open source is no longer just a way to develop software in such a way that is free. Frankly speaking, I lost all my hair in the process. If you see my photo in 2008, I had a nice, so I'm not so sure that this is the interesting part, because we've been there, done that. The interesting part is that the new paradigm is a necessity for a certain type of collaboration. And this is why the open source should count more than just the paper, because it enables ways of federation, collaboration, and comparison that cannot be done. In our areas here, we want to have papers with the GitHub pointer. I don't want to see papers which claim that there's a model without the GitHub pointers. I want to see the model. And that will enable the community to see the model. I'm stop here.
Can I ask a question to the panel?
Sure.
Something specific. Look, we've seen very clearly what's happening in the AI community over the past months. So let me ask specifically, there's an interesting fight happening right now between closed models with various reasonings for keeping them closed and open models with lots of good reasons to keep them open. Let me ask, what do you all think about this fight that's happening? How will it play out? How should it play out?
Well, I'll jump in.
Are some models too dangerous to be open, for example?
No, it's the reality of the matter. There is commercial reasons for keeping models closed, as we know. We started this discussion with argument which things should be closed, which things should be open. So there are certainly some commercial advantages, and those commercial advantages are important, of course. You know, it makes businesses go around and invest in science eventually, and do some important things. What I'm more worried about is commercial advantages gained using open source. That is where my worry is, that, you know, if you start to draw a line between where the source of the ideas are, and you find yourself in a location that was initially designed for non-commercial purposes, you know, the sources are, then does it make sense for those models to be open source, right? If all the sources, all those pieces of information that were used to create the intellectual property all belong to the organization that created it, yes, that makes sense. I mean, we own everything. We can trace back and we can see we own everything. But if we start to make things that dependent upon open things, and then we close them, we have to worry about that as a society. I don't know whether that
Might I generalize a principle?
Yes, go ahead.
Might you say that knowledge representations based on open data ought themselves be open? Whether they be language, oceans,
Well, I
astronomy?
would like to offer a specific example, if I may, so we may help. Because, for example, I also lead an institute, a research institute in the UAE. And in the UAE, in the United Arab Emirates, there was recently the announcement of a small footprint language model-based implementation. A small footprint means 40 gigabytes, meaning so you can use it in a number of places. You don't have to send data over the internet to the US. So there's a lot of interest. On the other hand, the notion is that the type of model is trained, and is trained based on data collected. And this data collected comes, especially if you want to do focus it on research, so it has to be helpful for the researcher for part in a certain number of verticals. That all the papers that are used to train the model come from the public domain, or so that model must be open. Sorry, I don't know what that model must be open, because this is exactly what makes the open science effort different from before. This is just my 2 cents, but I want to...
I agree with you. I agree with you. I think I'll be ready to sign that declaration.
So I think also that this needs to play out, right? So we have still not decided whether open source or proprietary software is the way to go. I think there is a huge pendulum towards open source software, but there's certainly really successful example for commercial closed source software. And of course, there are always, people who say, everything should be open source, and there are people who differ, right? And I think the same thing happens for models. I do think that there needs to be regulation. There need to be, we need to figure out what the copyright issues are when you do all this data and you kind of refine your models. Large language models that have been commercially recreated. There's an interesting development recently that some of the open source efforts are actually more efficient.
Yes.
That really scares commercial people, right? So it's not only the issue of what the source is, but also the very mechanics of how to actually run those. That shows that some of the open source efforts have actually a leg up, right? And so it's not clear to me what the force field is that determines what is going to be open and what's going to be closed. We could very well end up in the same situation as we are today, where we see that large parts of the software business is actually better off open source or open.
Yeah, to follow up on what Carlos said about that, it's actually really interesting to watch what's going on right now. And I think this applies in any scientific domain, not just in AI, but there's some sort of Google memo that got leaked, and I think it's called "There Is No Moat." If you want to Google that, it's really a good read, because what they're finding, what this person was arguing, is that open source is outstripping the innovation that Google and Meta and those folks are doing internally. So actually collaborating in the open is actually pushing the science of AI faster than people who are trying to be proprietary. Like you just can't have an advantage that lasts long enough to be worth it. You're just better off being out in the open with everything. And I think that's going to be true for science in general. You know, from my point of view, the way that AI will be successful for some companies will be applications, not just like our model's smarter than your model, because that's just an arms race.
Yeah, I'll chime in quickly. I think, again, a lot of this comes back to the incentives. And so maybe like what Carlos was saying, like, you know, free market, let's see what happens. But if the incentives, you know, lessen for commercial software where they're not, you know, getting the results and then they're not getting the money, you know, that they need or for, you know, commercial data or whatever we're talking about, then, you know, I think we will go more toward an open, you know, an entirely open software ecosystem. But I do think that there are some aspects of commercial software that might be more beneficial, at least how it stands now, where you pay someone and they do this job, which is not always the case in open source at the moment, where you might not have, you know, someone to maintain the package all the time, that kind of thing, which we're working on. But yeah, so I think it comes back to incentives, and I guess I'm also curious to see how it'll play out.
Very practically minded, but suppose that I wanted to make an application for writing love letters, right? I want to write love letters, so I take some very nice Italian poets and in impossible translations. And then what I'm basically doing is training a model, and then I sell it over the internet, like a sort of a way to sort of, you know, get attention from your loved one or whatever. So what I'm doing is an anti-common thing, because I'm taking public domain stuff, which is there for a reason. And by the way, it has been put in the public domain, but it also been stored, and there are costs that we are, at least in Europe, they go on the taxpayer shoulders to maintain this public domain available. So there was a very interesting notion of availability and accessibility, accessible, I should say, because in that case, there's no cost. But then I am doing the training cost. I'm shouldering the training cost. Now, by doing that, I'm sort of getting a commercial advantage of running the model. So this is fine. I don't want to you know, but if I don't want to see that in open science, it's fine if I added a nice service, I love you letters. That's okay, up to a point. But certainly, if this is something that goes in the pipeline of some scientific discovery, we are moving from love letters to, I don't know, chemical compounds, which is IBM, an IBM project which in Zurich, which is very interesting. And so in that case, if I train the model with the public domain, secondary literature, and then I use the model to do some sort of identification or promising chemical formula, well, the model must be open. Sorry, I just want to, because otherwise the anti-common would go in the disadvantage, again, of the community. So I just want to underline the difference between these two scenarios. It's fine to make money on the internet, although not so frequent as people may think, but it's fine to make money with the internet, but certainly the research pipeline, which open models must be open in the research pipeline. This is just
so I just wanted to add, and you know, there is a fundamental difference between how open science was done 5 years ago versus how open science will be done today and in future. And that difference is the amount of compute that will be necessary to replicate that science. And this is kind of what I alluded to earlier as well, that I really agree with you. If you train a model that is, you know, predicting properties of certain chemical bonds, and you publish the paper, you should publish the model. I very much agree. It's not very clear to me that a lot of scientists around the world will really be able to achieve reproducibility by that action.
very good.
That is going to be a challenge for open source science for the next decade. Is that the amount of computation that will be necessary for someone to reproduce results will far exceed what a typical scientist with a laptop has. right? And to me, I think about that a lot, and I worry about that a lot.
Yeah, I absolutely agree with that. I do think there's a distinction between a paper that is reproducible and having it be able to be reproduced by everyone. I think we want all of our papers to be reproducible. That's a main tenet of science. Ideally, we want everyone to be able to actually run it and show that. But I think they are separate. And but I do believe that the second one is really necessary, and it is very apparent when you go to a lot of different institutions that have different resources. That this is really one of the biggest things. And when I'm dealing with really big data sets in oceanography, and there's a new policy out from the journal that says you have to make your data available. I'm like, okay, cool. I now have petabytes of data, and that's a very simple sentence to add to your journal policy and say, hooray, like we're really here for open science. And in general, I'm supportive of these. But then it's our community has this huge burden, and we have to figure this out, which I think goes back to some of the questions we had at the beginning of what should be open. So I'm kind of straying, but I absolutely agree.
So come to my talk at 2 o'clock.
Excellent. I'll be there.
We all will. We all will.
Let me, we have a few minutes left, so maybe we'll let the audience ask a question or two. If you have a question, do you guys have the mic? Can you bring the mic to folks? Please, if you have a question, raise your hand. Are there any questions? Yeah, here's a question in the back.
So my question revolves around licenses and some of what was just discussed before. For example, when you open source something that has some commercial appeal that's science related as opposed to love letters. So I can tell you, and sort of full disclosure, my wife is an IP lawyer, former researcher in organic chemistry, and she's seen both the research side and now the IP side in a major pharmaceutical company. And I can tell you that the people that will be able to actually produce a drug, because there is no public entity that produces drugs, rely on being able to keep IP. The reason being that due to the cost of actually going to the physical testing through many stages and clinical trials, for every drug that succeeds, there is hundreds, maybe even more than that, that fail, and the cost is in the billions of dollars. And if we have an issue like GPL, where basically there is a license that is poisonous, and the moment that you say, well, we're using this model and it uses all of the chemistry information that's out there in the public domain, and then it also uses for training some of our internal data. But lo and behold, you have to actually now publish it outside. People will simply not do it because you're going to put in the work, and the generic pharmaceutical company anywhere in the world is going to pick it up and run with it. So it is an issue, and I don't think the high ideal, which I agree, as an ideal, science should be as open as possible, is going to conflict with reality when it comes to that. And it's something to keep in mind. And then the extra thing about licensing, what I'm seeing right now is through especially the preponderance of Git and GitHub, people are putting out stuff without even a license in the repo or anything like that. You don't even know which license they were thinking when they put it out there. I have no idea how people are possibly copying things without actually cloning and reusing, and then you have anything that's going to be reused through the fact that it's been harvested. At some point, some lawyers, not my wife, because she's specifically dealing with IP in chemistry, but some lawyers are going to be making lots of money out of this because we've somehow created a monster, and I don't know how we can untangle it, or at least that's my impression.
Yeah, that's why I said you should always add a license to your Git repos.
Yeah, very interesting, and I agree up to the point that there is a potential conflict. On the other hand, the generic models And if we want to go, we can go specific on examples, like, for example, a preliminary in silico testing of repurposing of certain molecules, which is a typical application in which you want to do that type of thing. You have a generic model, and the generic model is trained on the literature. And again, the literature is not property of the model owner. The literature is the property of the authors of the institution, and in case it has been made open access, that literature is a collective property. So the model trained on that literature has some, in a sense, rights to. So I don't think that the anti-common is per se. The anti-common means that the result of this model needs to be part of the IP of the person who runs the model, complements the training, because then that company will have to go the wet lab checks, because what the model tells you may or may not be correct, right? So, okay, there's a huge cost involved. So they will only do it if the result of the original in silico model is basically, in a sense, wrappable for them to. So I see this. On the other hand, there are some rights of the scientific community, of the taxpayer, of the overall. So we need to balance. And this is, in my opinion, an open issue right now. We need to balance.
And aside on that, yes, I understand that. And the only thing then that you have to consider is not only the fact that you may have added training data, but that in actuality, you may have actually modified the starting model architecture, and in the process of doing now these modifications, plus a lot of hyperparameter tuning, you've actually added value. Now, again, that has certain costs. What do you do then? It's a question. I mean, ideally, you'd like to release it out, but somebody paid the wages of everybody that did that.
I see my fellow panelists nodding, so you have a point.
Yeah, I think I would just add, look, you can call me an optimist, but I think that there's just tremendous momentum, even in industries that were very close to it for a very long time, like pharma, to be much more open. Open source, open data sets, to harness, right, open innovation. So I don't think that you need to have, a forced framework in all cases. I think that lots of things are becoming open on their own merits because there's more of a benefit to do so. Some things where a company needs to invest and has proprietary data and has a very specific market opportunity, they'll be closed, and they will always be closed, and you kind of need that to have that incentive. But I think overall, on their own merits, lots of technology is heading toward open, and even in those industries where that was not the case for a very long time.
The other way I think about it is it's kind of an economic decision. Even in science, there's sort of an economy of what am I getting if I make this available to other people? What am I giving up? And aside from the questions of whether you should morally be obligated to maybe leave something open because it was trained on public data or something like that, it's always an economic decision at the end of the day. Am I going to get more benefit as a pharmaceutical company by keeping my research closed within my environment? Or will I actually benefit by sharing? So sometimes you have to weigh it that way too.
I would just add that in my discussions with software companies, if the original intent is to keep the product closed source, and from the get-go decisions are made about which other libraries to use, which other products to use, import in that in the design and implementation of that closed product. So folks are sensitive to that when they make the decision to make closed source things. They do have to be more careful. They do have to make sure that their developers don't go out and copy code from Stack Overflow or something like that to create that product. So there is some awareness in creating a clean open source, a clean closed source product, but where the debate was whether to take majority of the open knowledge and then create a closed product without giving any benefit back to the society that has contributed to that. And that's kind of where the line becomes a little bit gray, in my view.
Thank you. Well, so I think that, well, at the end of the panel, I want to say a few words for additional resources and today. So first of all, I really want to thank Tim Bonneman, who is here, who is the program chair for the Open Source Science Symposium. He did a tremendous amount of work programming today. So we have talks starting at 2 p.m. Another thing, we have the Open Source Science booth, which Tim also set up. And you can stop by, learn more about this specific initiative, right? So we're trying to be the connector at NumFocus. So we invite everybody to join our interest groups. That's our mechanism, kind of bottom up, by discipline and also horizontally, like Map of Science reproducibility. So you are very welcome to stop by and learn more. And if you notice, Open Source Science on our t-shirts, it's an actual URL. So opensource.science is a website, which gives you all the pointers, right? So basically that's, a few notes, and please join us, right? We will continue, and obviously next year we'll report the progress at the next symposium. And I really want to thank all the panelists for their great insights. Thank you.
Thank you very much.
Thank you.
very much.
Thank you.